Good evening, everyone. Good evening.
Good evening, sir.
Evening, sir.
Evening. All right, good. All right, guys. I have to say, at the kickstart is that for the longest while, I've not had a math class, whether it be online or physical, where I can safely say I'm impressed with your performance. I've not had a group of students in a while. When we say in a while, it's been a while where more than half of the class meet the pass mark. So thumbs up to everybody in the class who met the pass mark. Some of you guys would have gotten feedback. Nothing too much, not a lot, but you got a little feedback based on what I saw. I tried to keep it positive as best as I can. If you didn't get a response, it would mean that you didn't submit any work, or you submitted the work but you didn't forward it to my personal email. So I only got one request, which was Sonia. Sonia did not get a response. Sonia didn't find your email, so you may need to forward it back to my personal email, because I think you sent it to the school.
Good night, sir.
Good night, Damoy. I didn't send it to me. So. Sonia?
Question. Not Sonia, Shani. I dropped off the paper physically. Can I pick it up physically when?
What is your name? Shani Hendricks? I have it in my hand. It's right here. Yeah, man. Enter already. I sent a message in the group telling you guys that you can pick it up physically when you're ready.
Okay. All right.
So I'm not going to call out anybody's grade, but I'm going to just call out the names of the persons who met the pass mark. And I set my pass mark at 45 for this first test, for this first assessment. So thumbs up to the following persons: Danica Walters. Right, you met my pass mark. Claude McKay, well done. You got perhaps the third highest score in the whole school. Somewhere, probably in the top 5. Shanika Heaven, you met also the pass mark as well. Patricia Beckford, you also did well. Stacy and Barrett.
Sir, Mr. Pierce?
Yes?
I'm sorry for always the misunderstanding. It's Shireen, but it's because I use another email. Beckford is actually my married name.
Oh, so it's you?
Yes, sir.
Okay. So Patricia Beckford is Shireen. Okay, all right, Shireen. So Shireen,
okay.
You did well as well. Stacy and Barrett, and she did talk to us last class, and she let us know that she forgot some stuff. So we're gonna work on that. But you got half the paper right, which is good. Roxanne Dixon, good job as well. You met the pass mark. Oshina Glanville, you met the pass mark as well. Akelia, very impressed by what I saw. Really good, right? You got perhaps the top 4 highest grade on this particular assessment. Leona, you did well, as expected. And Sabrina Williams, she got the highest in the whole entire school. So Sabrina, thumbs up to you, my dear. Really good job. Very impressed by the way how you articulated yourself on paper. That's really good, right? Any assessment at all you get 76% on is good. That's a grade 1 performance. Doesn't matter what level of math you're doing, that's a grade 1 performance. A good job. And last but not least, we have Kimona Glanville. I guess she's sister with Oshina Glanville, I'm assuming. So good job.
Shanika Heaven as well.
Shanika Heaven. I did call your name, you know.
Yes, but I'm saying they're my sisters.
Oh, they're your sisters. Okay. All right. Thumbs up. All right. So the other person did not meet the pass mark, right? And you would have gotten feedback. Pardon me?
You didn't call my name.
What's your name? Sonia? Is that you?
No, Nave Ferguson.
Oh, Nave. No, man. I responded to you, Nave. Oh, sorry, your name on the back of the paper.
Sorry, but you didn't call my name for the...
Oh, sorry, Nave. Sorry, your name is at the back. And Nave. Okay. Yes, and Nave, you got a good score. I think you met the pass mark as well. All right. So the other person did not meet the pass mark, which means that you have some work to do. I've texted in the group a couple times over the weekend, over the holiday, stating that the paper is there for review. at any time convenient to you. So if you know you didn't get a good grade based on my feedback, then it obviously means that you have some review to do. All right, and it's there for you at your time, at a time convenient to you. All right, so we're out with one phase and we're going into the next. Our last class, we started the topic of measurement, and we decided that we're going to make that particular topic our Thursday's topic. So today is Tuesday. We're going to jump into a new topic, right? Tuesday's topic, which we agreed that we're going to be starting algebra. Yes? That was what we agreed on. All right, so congrats to those person. All right. And the other persons, it's just a matter of you just finding out where you went wrong and just fixing it. That's all it is. A lot of you guys lost some marks because of incorrect signs. I did also saw quite a few persons being unable to understand the functions on the calculator as well. And that's a big problem. Unlike any problem, if you're unable to understand the calculator, which is going to be your best friend most of the time, you have to fix that and fix that fast. Because whilst it is okay when you can tell me, say, sir, I don't understand how to check the thing in my head, that can be fixed. But when you can't use the calculator, like you don't know where the square root button is or the cube root button or those things, you have to get that. Because it's very easy for you to just say, okay, sir, where is this button? And press it. Right? So we have to fix that. Have to fix that, guys. All right. I'm so sorry I didn't have the physical paper though, because I would have made some notes or some markings on it. Apart from Shani Hendricks and Latisha Lewis, I don't have a physical paper for anybody else. But that is that. All right. All right. So congrats to those persons. Good job. I'm really impressed by the group. Really impressed by the group. And I didn't see any signs of foul play. I feel like everybody genuinely attempted the test. I didn't see any signs of AI being used or, I mean, if anybody did that, then it's on you. Because if you get a high grade using AI, then it's not you. No, it's better you get a low grade knowing it's you than to use some assistance and get a high grade and feel proud of yourself. There's nothing to feel proud about if you got help. But with that said, that's out of the way, ladies and gentlemen. We have to move on. There are more pressing matters at hand. And so we're going to go into phase 2, which is now the important phase. You were exposed to one of the most important topics in math, which is measurement. We're going to pick up on that on Thursday. But for now, we're going to be starting our topic tonight, which is going to be algebra. I'm going to be sharing my screen now. All right. Really impressed by the group. No, like, I feel really good. Like, I come into this class today, I was like, all right, you know what? I'm happy. And I've been this happy in a while. It's like most of you pass the test. It's unbelievable. In a while, I haven't had a group that performed this good. So something I work. I don't know if I'm me or you, but something I work. Something is working. All right, ladies and gentlemen. So tonight we're going to be starting the topic of algebra. We're going to be introducing the concept, right? We're not going to be doing the history of algebra. That's too deep. It's going to be touching base on the fundamentals of algebra, right? And try to get it into some, basic understanding of this concept. Now we know how algebra go, right? A lot of persons have attributed algebra as being one of the hardest, I guess. It's safe to say one of the hardest topic. I don't know why them say it's the hardest topic. I feel like it's the most abstract topic. It's just one of those branch of mathematics that it's very difficult to apply the concepts of algebra to real life. All right. So it's just a thing where we have to just learn and know how to apply. But there's many examples of algebra being used in real life. And I'll try to highlight them as best as I can as I go through the lesson. But for now, let us go back to the basics, ladies and gentlemen. The basic form of algebra. Take down this information for me, please. All right, so just as a starter, all right, algebra is a notation, guys, notation. Algebra is an abstract branch of mathematics. Algebra is a abstract branch of mathematics. That forms a relationship. Algebra is an abstract branch of mathematics that forms a relationship between the known and the unknown. Between the known and the unknown. Between the known and the unknown. Full stop. An unknown value in algebra is represented by a letter in the alphabet. An unknown value in algebra is represented by a letter in the alphabet. Such as X, Y, A, B, P, Q, and I can go on and on and on. Right? Now the reason why I've chosen those letters because those are the letters that all right, hi Leona. For that first part of the class, was it saved or it's going to go away? Do you know?
I didn't stop recording, so it will go away.
Oh, so it was still recording. Okay, all right, noted. Thank you. All right, guys, yeah, the light just get chip out a while ago and come back, so we're back at it. Let me jump back onto sharing the screen. All right, guys, can somebody remind me of the last part of the statement I just made? Got interrupted.
The examples.
Or the examples. All right, I think I was saying something in regards to all right, so we were saying that these are the most commonly used letters, right? So X, Y, A, B, P, and Q are the most commonly used letters. So these are the ones that you're going to see me using most, if not all my examples. Okay? All right. So these are what we use to represent things that we don't know. So we can say that I have X amount of pencils in my pencil case. I can say I have Y pairs of shoes in my closet. I can say I have A amount of apples on my tree. I can say I have B amount of bananas in the basket. I can say I have P amount of pumpkins on the farm. I can say I have Q amount of dollars in my bank account. So pretty much we just use a letter in algebra to represent something that we do not know. Now, apart from that, we use a letter to state what we don't know. It has a name. We have a name for it. So please write this for me, guys. An unknown variable, an unknown quantity, represented by a letter, an unknown quantity represented by a letter is called a variable. That's the term, that's the mathematical term that we use. It's called a variable. So if you were asked for whatever reason to define what an unknown quantity is, or to define what a variable is, you'd say that a variable is a letter that is used to represent an unknown quantity or something of that sort. All right, now we're going to look at a variable that is more common to us, right? Something that we're going to see, because obviously we're not going to just see X, Y, A, B, P, and Q. And I know that there's students in here that has experience and be like, okay, sir, this is the easy part of algebra, right? You're going to most likely see something like, I'm just going to write something simple. Let's keep it very simple. Let's say 3x squared, right? That's a very common type of algebraic expression that you're going to encounter. All right. Now, every single variable in algebra has 3 parts. Every single variable in algebra has 3 parts. It has a number at the front. It has a name. The letter itself has a name. And the little number at the top here also has a name. All right. So the number at the front, the correct name for it is going to be called the I think it's EFFECIENT. So it's coefficient. So the number at the front, any number that is at the front is called a coefficient. Let me try to write that a little bit better. My handwriting is a bit atrocious. So any number that appears before a letter in algebra, we say it's called a coefficient. So that is COEFFICIENT. It's called a coefficient. Now, the letter itself is called a variable, right? It's called a variable. But occasionally, you'll hear me use the word base interchangeably based on conversations, based on the type of explanation that I'm bringing across. So the letter itself is called the base. It's the base of the expression, right? And the number that is at the top there, which is the 2, it doesn't have to be positive, guys. It can be a positive number. It can be a positive whole number. It can be a negative whole number. It can be a positive fraction. It can be a negative fraction. At this level, we're not going to get any with a decimal, but it's possible that it can be a decimal as well. That number at the top there is called an E. It's called an E exponent. So it's EXPO exponent. All right, most of you guys are familiar with the exponent as being called a power. So we can also use the word a power as well, POWER. So it's called a power. All right. So every variable has these 3 parts. All right. It has a coefficient. It has a base. Otherwise, let me just put / variable. And it also has a power. Every expression of that. Now, together, when you put them all together, the number, the base, and the power, when you put them all together, it is called an algebraic expression. So it's called an algebraic, so that is ALGEBRAIC, algebraic expression. EXPEPRE, pardon me. Is it 2S or 1S? Expression. Oh, I think it's 2S. Right. Good. All right. So the number is called the coefficient. the letter is called the base or the variable, and the little number that is at the top, whether it be a fraction, a decimal, or a positive or negative whole number, is called an exponent or a power. And when you put them all together, we get what is called an algebraic expression. All right, it's called an algebraic expression. Now, let us go to something that I've heard over the years, right? Different students have been exposed to different types of teaching. But have anybody ever heard a student or somebody say that when they see this letter X, just see X alone, you often hear them say X is 1? I'm sure you might have heard that before, that people say X is 1. All right. Now, whilst I understand what you say when you say X is 1, the correct way of saying it is that the coefficient of X is 1. X is not 1. X can be any number. X can be 2, 3, 4, 5, any number. So the correct way of expressing it is to say that the coefficient of X is 1. What we're trying to say is that the number that is in front of X is 1. And we're also trying to say that the number, the power, the exponent of X is also 1. So going forward, ladies and gentlemen, when you see an expression, any expression like that, where there is not a visible number in front of the variable or in front of the base, when you don't see the actual number, then the number that is understood is 1. Means that we already know say 1. Do you have to write the 1? You don't. Do I write the 1? I never write the 1. I just know that it is a 1. All right. So it is what we say in math, that it is understood. So going forward, guys, we're not going to say X is 1 because X can be any number. It's the coefficient of X that is 1. And also the exponent of X is 1. And this doesn't just apply to X. It just applies to any letter. That means if you see the letter A, that means the coefficient of A is 1 and the power of A is 1. If you see Y, the coefficient of Y is 1 and the power is 1. All right, so it goes for any letter of the alphabet, any letter that is being used in the algebraic expression. If the letter is all by itself, then there's an understood coefficient and an understood power of 1. All right, everybody clear so far?
Yes, sir.
Very good. All right, another ambiguity that pops up is students get a little confused when they start to see a wide variety of different types of expression in math, right? And also another ambiguity is students tend to confuse and they use the word equation and expression in the wrong context. We're not talking about equations, guys. We're not at that stage as yet. So we won't be dealing with any equal sign. We won't be dealing with any transposition. All that we're talking about, guys, is an expression. An expression is not an equation. Now, for the purpose of knowledge, we have several types of expressions in math. We have something with them called monomial expression. And we have something then called binomial expression. And this is just for knowledge sake, ladies and gentlemen. It's nothing that I'm asking you to study. It's not a case where CSEC is going to ask you to define these. So when we say monomial or monomial expression, right? The prefix mono means 1. So it means then that this is an expression that consists of only one single letter. For example, 2x. 2x is a monomial expression because the expression only has one variable. And even if you have 2 letters joined on together, because people think that monomial means like one letter, like one single letter. This also is what you call a monomial expression as well, 2xy. It's just that it's called a composite monomial expression, meaning that 2 letters join on together to form 1. All right, but we'll elaborate more on that later on. But the prefix mono means 1. And the prefix bi means 2. And this means two separate letters coming together, or there's two separate letters being attached together by a plus sign or a minus sign. For example, we have 2x plus 3y. That is what we call a binomial expression. The x and the y is separated by a plus or a minus sign. That's when it becomes a binomial expression. So don't get them confused. Up here, so we see x and y, but they are joined together. So it's still a monomial. It's just called a composite monomial expression. And the one at the bottom, 2x plus 3y, they're separated by a plus or a minus sign. So that's why we call it binomial. All right. And then you have trinomial expression, which is three different letters that is separated by a plus and or a minus sign. Okay. So don't get them confused. All right. Now we'll elaborate more on that as we go deeper. You'll hear me use these terminologies again and again. Now, we need to have an understanding of two very important segregations in algebra. We have to segregate and have a clear understanding of something known as like terms versus unlike terms. We need to know what they are, what makes terms in algebra like, and what makes them unlike. Because this can be very confusing for like a lot of people, right? If you're not able to determine and segregate when terms are like versus when they are unlike, along with the rules, because there's certain things that you can do with like terms that you cannot do with unlike terms. All right? So we're going to be looking at what are like terms. Write down this definition for me, guys. So your subheading or your sub-question is what are like terms? Or your subheading is going to be like terms, so you underline it. Like terms are terms, and the word term is the same thing as the word expression. So we use term and the word expression interchangeably. So like expressions are like terms. All right. So like terms are terms. Like terms are terms. That have the same algebraic base and power. I take out the word algebraic. It has the same base and power. It has the same base and power. So like terms are terms that have the same base and power. So let's look at some examples. All right. Because these can be confusing. All right. So the easiest example here would have been to say 2x, comma, minus 3x, comma, a half x, comma, 1.9x, comma. Now, if you'll notice that the numbers at the front differs, but one thing that remains constant throughout all four expressions is x, 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 and x. So, just to make it clear, it is not the coefficient that makes the terms alike. It is the base that makes them alike. Now, careful now, because in example number 2, you'll realize where the terms will have the same base, or they look like, well, they have the same base, but the power is changing. If you look good at this, the power here, you don't see a power, but we just explained that when you see a letter without an visible power, the power that is understood is a 1. So the power here is 1, the power here is 1 as well, the power here is 1 as well, and the power here is 1 as well. So notice that according to the definition, like terms in algebra are terms that have the same base and the same power. Now, this is what we call a monomial expression, right? They all have one letter that is their base. Example number 2. We have something them called exponential base, meaning that the base has an exponent. That's why we call it exponential base. The base has an exponent. So example would be something like negative 4y cubed half y cubed uh 8.2 y cubed 3y cubed. So notice for these examples, the base is not just the letter y. The base also includes the power as well. So the base of this expression, is actually going to be y cubed, y cubed, y cubed, y cubed. That is what's making them alike. It's not just the y alone. It's y cubed, y cubed, y cubed, y cubed. That's what's making them alike. Notice that they all have a y base and they all are raised to the power of 3. 3, 3, 3, and 3. That's what's making them alike. Now, another type of expression that you will encounter, right? Another type of expression that you will encounter is something that we call composite base. We mentioned it earlier, but now you're actually going to see it in person now. So when we have a composite base, it means that we have more than one letter coming together to form the base. So something like 3/4 AB, 2.9 AB, 10 AB, -7 AB. The base is not A and the base is not B. The base is AB, 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 and AB. That is what's making all these terms being classified as like terms. So example number 1 is what we call a monomial base. Example number 2 is what we call an exponential base. Example number 3 is what we call a composite base. And then of course, we have another one. As I said, most of these you may encounter when you are the type of student that is very inquisitive. Somebody said hello? Okay. All right, so if you're the type of student that will meet up on textbooks or your practice and you'll be like, oh, this looks funny, this don't look like something that's her teaching class. I'm exposing you to all the different types of expressions in algebra. All right, so the last one now that I think you will encounter is something called an exponential composite base, where one of the letters in the base is risen to a power. So you can have something like, let's say 2x squared y, -3x squared y, minus, let's not do minus, we just do minus a while ago, 1/4 x squared y. And we have 0.7 x squared y. Please note, ladies and gentlemen, that the base is not x, the base is not x squared, and the base is not y. The base is actually x squared y, x squared y, x squared y, and x squared y. So the exercise that we just went through, or we just complete moments ago, guys, this is the big confusion why a lot of students are having challenges with algebra, especially when you're in the middle, because they don't know what are like terms. They don't know what makes terms alike. So this is where the challenge is. All right. So in summary then, to classify a term to be alike, or as I'm saying, like terms, they have to have the same exact base, and they also have to have the same power. If there's any difference between them, if them just look partially different, they are going to be classified as unlike terms. Is it clear, everybody?
Yes, sir.
Everybody good? Everybody good?
Yes, sir.
Sir.
Not really, sir.
Talk to me. Which one am I losing?
Man, I can't. Stop it. It's kind of. Man, no,
Go
sir.
ahead, man.
I'll go back over the video, over the recording, and try to get it.
No, it's fine. We'd love to hear your opinion. Like, what is it that you're looking at that's kind of giving you like a blurry vision?
Sorry, I hear me?
Yeah, me, I hear you. Kind of muffled, but okay, go ahead.
Yeah, the disconnect and we are trying to speak my mic at work and kind of missed the little part in the beginning where you talk about unlike and like terms, but we just followed what you know, kind of understand a little bit, but you know, I also
You have the recording, so anything you miss, you can catch it back. Anything that you miss, you can catch it back. Plus, as I said, as I'm going through, I'm going to reiterate almost everything that I said, but I'm going to be doing it in stages. All right. So, as again, just summarize this. For something to be classified as being alike, it have to look the exact same way. Same power and same base. All right. Now, maybe when we explain unlike terms now, then it will make a lot more sense to you. All right. So watch out, guys. This might be a little tricky. Just a little tricky. So watch out. Unlike terms. If something is unlike, there's a difference between them. There's something different about them. It's self-explanatory. Unlike terms, meaning that something different about them. Now, the first example is the most obvious one. Like, anybody will pick up that these terms are unlike. Oh, sorry. Let me give you the definition first. Write this down, guys. Unlike terms are terms. Unlike terms are terms. Unlike terms are terms where either the base or the powers, where either the base or powers are different. Where either the base or the powers are different. That's as simple as that. Okay. All right. Let's look at some examples. I feel like examples give people clarity. So if I ask you to confirm if these terms are like or unlike, 2x 3y negative 5t 2.8 a half b. It is very evident that the terms are unlike, because the base here is x, the base here is y, the base here is t, the base here is a, and the base here is b. Very evident, not true? Unlike terms. I don't think anybody will have a problem with that. Here is where it gets tricky. What is going on? Okay. All right. So here's where it gets tricky now. Example number 2. 3x squared, comma, half x cubed, comma, 1.5 x to the power 4 negative 8 x to the power 5. Why am I categorizing these terms as being unlike? What is it that you see why you think I would say that these are unlike?
The exponent.
Anybody?
Powers are different.
The powers are different, not true? So if you look at it carefully, you might be tempted to say, then sir, this can't be unlike. They all have x, not true? Yes, they all have x. But are the x's risen to the same power? There is a difference between them. And the difference is occurring in the power. That is x squared, that is x cubed, that is x4, that is x5. They belong to different families. X squared can only be grouped with x squares. X cubes can only be grouped with x cubes. X to the 4 can only be grouped with other x's that are risen to the power 4. Vice versa. X to the 5, sorry, not vice versa, but similarly, x to the 5 can only be grouped with terms that are risen to the power 5. All right? So, carefully, easily can get tricked if you're not paying attention. It gets trickier. It gets trickier. Number 3, these are all fundamental concepts in algebra now that, like I said, majority, if you go on YouTube or anywhere and look for like lessons on algebra, these things are, we kind of assume that you're supposed to know this. But I don't assume that my students know these things. I make certain that I take on 25 minutes or 30 minutes and clear it up, because when I start bringing you into the deep part of the ocean, I don't want nobody ball out so them can't swim. So I teach you to swim from now. Example number 3. (5a to the 4th negative 2b to the 4th. Put a comma there. Comma again. Half x to the 4th, comma, 6.2 y to the 4th. You can get tricked easily. Perhaps not you, but somebody out there will get tricked easily. What could trick you? What is it that is in these set of expressions that potentially could make you feel like they are alike?
They all have the
same exponent.
They all have the same exponent, but what is making them unlike?
The base.
The base is what's making them unlike. This is A, this is B, this is X, and this is Y. So regardless if they have the same power, them still unlike. Them still unlike. They have to have the same base and they have to have the same power for you to categorize them as being like. All right? And the final example, All right, and this is the trickiest one of all. It is so confusing. I think, in my opinion, like I think if I'm learning this for the first time, this exam would perhaps confuse me the most. This one, I feel. That's what I'm thinking, that this one is going to trick me the most. Look good now, you know. Very tricky. 2a squared b, comma, 3ab squared, half a squared b squared, 6ab. Tricky, tricky, tricky. Why do I categorize these as being unlike? Sir, but the whole of them have A, B, so how come you say they unlike? Go ahead, Kevin.
So the exponents are in different places, sir. Like the 2a squared b, sir. The a and the b separated by the 2.
Correct. You said it perfectly. In one sentence, you said it perfectly. The exponents are in different places for each. In example number 1, the a is squared, but the b is not. In example number 2, the a is not squared, but the b is squared. In example number 3, both the a and the b is raised to the power of 2. And in example number 4, none of them is raised to the power of 2. But again, students can easily get tricked, because if you're not paying attention to these subtle details, you might say, sir, they're all alike because they all have AB. But they all have AB, but one letter have a power and the other one doesn't. Now, when I zoom out and you look at this, ladies and gentlemen, do you now understand why people say algebra is difficult? It looks all like a bunch of something put together when it make no sense, not true?
Yes, sir.
But when you actually tune into a class like this, or even other teachers that are out there that really breaks it down like this here, right? Because I'm not the best in the world. But when you break it down like this, then students begin to understand, like, okay, so that is what Sarah's saying. So that is why they must say this is like or unlike. It's the understanding behind what makes terms alike and what makes terms unlike. The student who earlier said that she may have to watch over the video, are you getting some level of clarity now? Is it making a little bit more sense to you?
Yes, sir.
Okay. All right. Is there anyone that has a particular question? Is there a particular example that I wrote something on the screen and you be like, sir, go over that one day again? I mean, 100% get it. Is there something on the screen, whether in the previous slide or this slide, that just maybe you want to go over a little bit?
Sir, the like one.
Like one.
Yes.
This one.
Yes, sir.
All right. Let's run back through it again so make sure it's be clear. Why we say them like is because they all have the same letter and they all have the same power. In example number 1, all expressions are x to the 1. X to the 1, 2x to the 1, negative 3x to the 1, half x to the 1, 1.9x to the 1. In example number 2, they are all risen to the power of 3 and they all have a base of y. So negative 4y cubed, half y cubed, 8.2y cubed, 3y cubed. In example number 3, their bases are composite. The term composite used in maths from, well, the word composite means more than one from the English dictionary. But in maths, we kind of mean the same thing too, where more than one letters come together, merged as one to create the base. So the base is not A and the base is not B. Combine them, the base is AB. So we have 3/4 AB, 2.9 AB, 10 AB, negative 7 AB. And the last example is where we combine exponential quantities, or I call it exponential composite expression, where one of the base is risen to a particular power. So the base is not x, the base is not x squared, and the base is not y. You combine them together, and the base is x squared y. So we have 2 x squared y, negative 3 x squared y, a quarter x squared y, 0.7 x squared y. Is it clear?
Yes, sir.
So, all right. Now, the rules. Rules. There are things that we can do, and there are things that we cannot do. All right? And these laws have to be obeyed. Just like when we were discussing the topic of PEMDAS, right? I will say that things have to be done in a specific order. It's the same thing here. There are things that you can add, and there are things that you cannot add. There are things that you can subtract, and things that you cannot subtract. There are things that you can multiply, and there's some things that you cannot multiply. All right, so we're going to be segregating them. So we're going to draw a line here like a little table. Let me zoom it out a little bit here. Okay, we're going to put like terms on one side, and we're going to put unlike terms on the other side. We're going to be discussing what we can do and what we cannot do. We're not necessarily work out anything, you know. We're just looking at what we can and cannot do. All right. So for the like term, right? If I say to you, simplify, because that's the word that we use the word simplify. We don't use evaluate or determine. It is always this word, simplify. So simplify, that's the word that we use. Two x plus 5x. Let me write it a bit small. It's a little bit too big. So 2x plus 5x. It's possible that we can add that. There are some persons that them hate maths with a poison. Them hate maths like poison. Them hate maths with a passion. That they start to stigmatize the topic and say, sir, me not understand when you add letters. We don't add letters in algebra, ladies and gentlemen. We do not do that. It's not possible to do that. What we're actually doing, ladies and gentlemen, is that we're adding the numbers that are in front of the letters. That's what we're doing. So 2x plus 5x is like me saying 2 apples plus 5 more apples equals what? 7 apples. That's all that I'm saying, you know. The x is just representing something that we don't know. So we can remove the x and say that the x represents an apple, a banana, a pumpkin, yam. So 2 yam plus 5 yam equals 7 yam. 2 apple plus 5 apple equals 7 apple. 2 banana plus 5 banana equals 7 banana. So the x is just representing an object, so to speak. So 2x plus 5x is equal to 7x. Here's where it gets a little tricky, right? Because sometimes the deeper you go into math, as students, we tend to always forget our roots or our fundamentals. So when I give a student like this a question in class and I say, evaluate 9x minus 13x. They will perhaps write down an answer that is very close to the correct answer. But let us just remove the x. Remember the first day you guys met me? Remember the first day you guys met me, we started a topic known as operations with integers, right? And if the x wasn't there and I asked you to calculate 9 minus 13, we would have used the O and half technique, not true? Because we obviously know that we can't type a letter into the calculator. So we would have used O and halves. At this level, you could just type it in the calculator and it tells you the answer is -4. But we have a method that we use, a fundamental concept known as O and half. So the 9 is the positive and the 13 is the negative, not true? So that simply means that the 9 is an amount that you have and the 13 is an amount that you owe or is an amount that you borrowed. So that concept from day one when you met me is still being applied now. So the answer here is going to be -4. So I'm going to just put what my x's now. So 9x minus 13x actually equals -4x. Okay? And similarly, if you end up with a situation like -a plus 5a, students will also forget that the a, you will hear students now will say, sir, a is 1. Please stop saying that. A is not 1. The coefficient of a is 1. Sir, you know what I mean. I know what you mean, but you're not saying what you mean. So -a plus 5a is like me saying -1 plus 5. Because remember that the understood value right here is a 1. So, sir, why you don't write it? We don't write 1. At no given point will you, the only number that you will not see an instructor write in algebra is 1. We don't write it because it's understood. So you have to remember that when you see the letter by itself, it means that the number that is in front of that letter is 1, which in this case is -1. So I'm going to leave it there in red, just so you remember. So -a plus 5a is similar to me saying -1 plus 5. The -1 is an amount that you owe, and the 5 is an amount that you have. So if you pay the 1 that you owe from the 5 that you have, then you'll end up still having 4a. If you've missed that class, well, everybody knows all my sessions are recorded. So if you missed that class or you want to, if you're new, I think there's a new student by the name of Gail. I think she texted in the group, so I'm not sure if she's here. She might be, I think she might be, I'm not sure.
Yes, sir.
But yeah. Oh, you're here. Okay. So if you miss out on that session, right, then you can always revisit my channel and you'll find a link to that particular. If you can't find it, then you just DM me personally and I'll send you the direct link to that particular session. So -a plus 5a is 4a. All right. So don't get it confused, guys. We're not adding letters and these things in algebra. We're not doing anything with the letters. The letters are being written back. It's the numbers that are in front of the letters that we're focusing on. Okay. So yes, ladies and gentlemen, you are allowed to add and you are also allowed to subtract unlike terms. But sorry, like terms, pardon me, ladies and gentlemen. But is that the same situation with terms that are unlike? Let us test it then and let us find out. So over here now, we're saying that 2x plus 3y. And you ask a student, what is the solution for 2x plus 3y? So you ask a student, what is 2x plus 3y? And they'll tell you that, sir, my last teacher told me that 2x plus 3y is 5xy. No teacher not tell you that, I'm sure. I'm 100% sure. I'm going to vouch for all the math teachers in the world. A math teacher is not going to tell you that 2x plus 3y. You assume that 2x plus 3y is 5xy. Ladies and gentlemen, you are not allowed to add terms that are unlike. If I say to you, What is 2 bananas plus 3 apple? Are you going to tell me that the answer is 5 apple banana? Or 5 banana apple? Is there a fruit by the name of banana apple? I'm being theatrical, but I need to bring that across so you understand that that is like a carnal sin in math. You trying to add that is like you telling me that when you put an apple and a banana together, you get a banana apple or an apple banana, and there's no such thing as an apple banana. 2 apple plus 3 banana is equal to 2 apple and 3 banana. So the answer for this is the same thing. 2x plus 3y. That's what it is, nothing else. Okay, ladies and gentlemen, you are not allowed to add them, nor 5a minus 2b. Please do not take the 2 away from the 5 and say the answer is 3ab. That is not allowed. You can't do that. So 5a take away 2b. If you happen to happen to have gotten a question and you're asked to simplify the expression, and throughout your simplification process, you reach at this stage in the question, then when you reach this stage, that is the end of the question. So 5a minus 2b, the answer is 5a minus 2b. Is it clear, ladies and gentlemen?
Yes, sir.
Are we clear on what we can do and we cannot do?
Yes, sir.
All right. Now, let us test it for sure. Let us test it for sure. The verb that we use, you're going to see this word so often. You're going to tell us that word here, so get used to it mean. The word simplify simply means to break down the expression to the point where you can't go no further. For example, 5a minus 2b, you can't go no further than that. That's where it stops, can't go no further. So simplify two a minus 3b minus 7a plus 5b. I have some experienced students in the class, so they most likely will tell me what is step number 1 to simplify this question. Anybody can jump in. Go ahead. What do you think we would have to do here?
You group the like terms.
You group the terms that are alike, not true?
Yeah.
So we call it, well, I used to call it the GLT method, but you know, different students learn different ways. You use an acronym on the students and you start to throw them off. But it's called the GLT method. So the GLT means group like terms. So you put the terms that are alike together. Here's the trick with this now. And believe it or not, people, a student will get a question like this, and 2 things will make you get it incorrect. Students often think that expressions and equations are the same thing. And especially when you have experience and you've been to multiple different math classes, you're all confused. So watch this now. All right. A student will say, all right, group like terms, no problem. So they'll write the 2a here. And what they do is that the sign right also, this sign here, so then bring it down. That's not the sign that you bring down. You bring down the sign that is in front of the term that is alike to the one that you're grouping it with. Not true? So in this case, it works out that the 7a has a minus sign. So yes, minus sign come down. It is not this minus sign that come down, and that minus sign come down. It is this minus sign that you brought here. So that is negative 7a. Not true? Together there, so. Then now you carry the negative 3b there, so, and then you bring down the plus 5b. Now, let us clear up another ambiguity between transposition and grouping or rearranging. And the best way I can explain this is, if I'm in a classroom and a student is in the left side of the classroom, right? And I ask the student, can you see the board? And the student said, no, sir, I can't see the board. And I ask the student to move to the right side of the classroom. By that student moving to the right side of the classroom, did that student change their clothes? Did their complexion change? Did their feet get bigger? Did their eyes get smaller? No. The same way how them look on the left side of the classroom is the same way them are going to look when you're on the right side of the classroom. That's a perfect example of rearranging or grouping. You move the term from its current position to a new position where you don't change anything about it. Transposition, on the other hand, now, which is something we're going to talk about later, is where you change the sign. And a perfect example of transposition would be you come to class Tuesday in a red blouse and a black pants, and then Thursday you come class in a white blouse and one blue pants. You transpose means you change over, you look different. So if you were negative, you become positive, and if you were positive, you become negative. If you were being multiplied, you're now going to be divided, and if you're being divided, you're going to be multiplied. That's a perfect example of transposition. We are not at the stage in algebra where we are transposing anything. We are always, for the next few classes, we are going to be rearranging terms. So now that we clear up that little ambiguity there, we can now proceed now to say, all right, then the terms are now grouped. So now you need to pay attention now to that sign. You can't forget your fundamentals. 2 take away 7 is saying I have 2 apples and I, oh my God, is borrow or O? All right, let us use O. So I have 2 apples and I had borrowed 7 apples from somebody. So I can give them back 2 of the apples that I now have, and I'm still going to owe them 5 apples. So I owe them 5A. Signs give people problems here. Sir, what sign we must write down? Your sign that you write down is based on your understanding of our fundamental class that we learned when you first met me. O and have. Please do not forget your roots, your root class. Those things were not taught in vain. They were taught at the first thing we teach because we know it. I know it's something that's going to be following you everywhere you go. So we don't just teach it for teach its sake. We say, okay, it's fundamental math. We teach it because it's something that us maths teachers, students suffer with these things. As they go deeper and deeper, they tend to forget things that they learned at the beginning. Next one. Students have a tendency to say that this number right here is 3. So what they'll do, and you're going to find, believe me, even though I'm telling you now, you're going to find yourself doing it anyways. They'll say 3 plus 5 is 8 and say the answer is negative 8b. You have to stop doing that, guys. It's going to cost you marks. That number is not 3, ladies and gentlemen. There's a minus sign that is in front of the 3. So it is not 3 plus 5. It's really negative 3 plus 5. And the way our work out that is the negative 3 is an amount that was borrowed or owed, and the 5 is an amount that you now currently have. So if you pay the 3 that you borrowed or you owed, and you now have 5, when you pay that 3 where you borrow or you owe, then you're simply going to have 2 left over. And if you notice that the sign that is right here, I never hit my carry down. So you have some students that are very quick to bring down that sign and then say 3 plus 5 is 8. Please, you need to stop that because it's going to cost you marks. And even though you have an understanding of the concept, based on where you made the error, I can't give you not even half a mark. Because your group like terms, all right, fine, I give you half mark to group it correctly. But when you're required to add and subtract, I'm going to take a whole of 1.5 mark. Or one and a half mark, yeah. Right. So I can't always give you half mark because your group, because anybody can group anything. So I'm going to brutally have to take out the whole entire marks if you make an error like that, because this is something that we've been through. So -3 plus 5 is saying 3 is what is owed, 5 is what you have, pay what you owe, and write down how much you have left over. So your answer is -5a plus 2b. At this stage, ladies and gentlemen, you cannot go any further. So this becomes your final result. -5a plus 2b. Is it clear?
Yes, sir.
Let us do another example. Notice me not rush the class. Me not ever teach the multiplication yet. So that at the next class. Taking my time. Because when we start move fast, I don't want none of these things to be a hindrance to us. 2x squared minus 5y squared plus 6x squared minus y squared. Careful. Once you don't like maths to a certain point, and if you don't like it, it will confuse you. Because you'll be like, then hold on, wait then. But all of them may have square. So you might be tempted to be like, add and subtract all the numbers. They all have square, but look at the base. The base is different. We have x square bases and we have y square bases. And we spoke about this in our categorization of like and unlike terms. So in this case now, we're looking for a term that has x squared. We have 2x squared. Please do not bring down the sign. You don't know.
Is it plus?
No, I'm just saying that don't bring down that minus sign.
Oh, no, I was trying to work it out, but I put the plus.
No, it's plus.
Okay, good.
Plus, because the plus is in front of the 6x squared.
Right.
So we're saying that do not bring down this minus sign. Because that minus sign belongs to the 5y squared. The plus belongs to the 6x squared. And then we're going to have minus 5y squared minus y squared. Now everybody is grouped accordingly. Now, 2x squared plus 6x squared, mentally just ignore the x squared, guys. 2 plus 6 is 8. So that becomes 8x squared. Careful now. Careful now. Minus 5 minus what?
1.
Good. Minus 1. Sir, why not just write the 1 and stop stressing me out? Me now go write the 1. I'm sorry. It's the only number that you're not going to see written on an algebraic paper. You're never going to see 1. You're going to see it just like that. So minus 5 minus 1 means that you borrowed 5 and you borrowed 1 more on that 5. So now you end up borrowing 6y squared. And you have that student now. Want to turn water into wine. And them just hell-bent, them determined, so they want to subtract this y squared from this x squared. And they end up with 2x squared y squared. Awesome funny something. No, Remind you, so if you do this, guys, and then you go write foolishness at the end, depending on the mood that I am in, maybe just give the whole question wrong. I will just give you the whole question incorrect. Because I don't expect any of my students that I've been teaching to subtract this too. You cannot subtract it. So 8x squared minus 6y squared is simply what you see here. 8x squared minus 6y squared. Is it clear, ladies and gentlemen? Ladies and gentlemen, is it clear?
Yes, sir.
Just one more example before we get out of here. All right, just one more example before we get out of here. One that will confuse you, as I say. You have to look carefully out of your eyes when you're grouping things, when you're putting things in groups. If I have a bunch of people in the class with red blouse, blue blouse, white blouse, gray blouse, black blouse, orange blouse, you must can look in at the room and say, the lady in the back in orange, the lady at the side in orange, the lady at the front in orange, and the lady to the corner in orange, please sit together. Oranges sit together, blues sit together, white sit together, black sit together, gray sit together. So you have to be able to practice your brain to realize these things. So if I write something like simplify two x squared y minus 3x y squared 2x squared y minus 3y squared minus 7x squared y plus 4xy minus 11xy squared. If I was learning this, I would have confused if I didn't attend this class. But all my students that are in this class, you can't confuse them with a question like this. It's near impossible. Because all my students, them know that all they have to do is look for the terms that look exactly alike. Now, taking out my red ink. The first term I'm going to try to group is the one we miss it first. X squared y. Using numerical positions, which term looks exactly like 2x squared y? Second, third, fourth, or fifth term?
Third.
So you're saying that this and this is alike?
Yes.
Agreed.
Yes, sir.
Agreed. All right. Which term now is alike with xy squared? The fourth or the fifth?
Fifth one.
Pardon me?
Fifth.
No, you hear that?
The fifth one.
The fifth one. So I'm going to put one rectangle. Boom. And boom. It's my paper. I want to mark up on my paper. And then, so sir, what happened to that 4xy? Him not have nobody to group with. So you leave him alone. Him not in trouble you. So leave him alone. Don't interfere with him. Focus on what is alike and group them together. And if you don't have nobody that is alike, stay by yourself. You're alone over there by yourself. Stay over there. So let us regroup then. Before we start add, let's regroup. Now the students that are a bit fast and more advanced, you can literally do it in your mind. I don't. I can, but I don't. I always regroup. So I go ahead and say, all right then. I use my red ink to group this then. So I'm going to say 2x squared y minus 7x squared y. Then I'm going to use my blue ink now. We're going to have minus 3xy squared minus 11xy squared. And then I'm going to have now plus 4xy. All in different colors. So red, blue, black. 2 take away 7. Talk to me.
-5.
Minus
-5 x squared y. Careful now, you know. Do not bring down this sign unless you're sure you want negative. Check it first, because sometimes you see one negative here, so, but when you calculate, it end up being a positive. So don't bring down the sign. Check it first. -3 take away 11.
-14.
Excellent. -14 x y squared. And then you bring down your plus 4x y. And that is your final result. Do we understand, ladies and gentlemen?
Yes, sir.
Yes, sir.
Yes, sir.
All right, though. If you want more clarity, of course, Leanna records the class and I post it on my channel. If you feel a little bit confused, then by all means, feel free to rewatch the lesson and so you can get some clarity. All right, ladies and gentlemen, we will do a review on this next week Tuesday. And then we're going to move into the whole multiplication and division aspect of algebra. Okay? So next class, we're going to be looking at triangles. Because we looked at rectangles already. And we looked at squares. So we're going to move into the triangles next class. All right, ladies and gentlemen, thank you so much for joining tonight's class. Look out for the recording anytime tomorrow. Okay? Have a good night.
Good night, everyone.
Good night, everyone.
Good night, everyone.